Hello and welcome to Anandajit Hub. I'm Alakananda
And I'm Abhijit.
and we are brother and sister. We are so excited to have you here on our channel where we bring you fun and educational content that you're sure to enjoy. Today, we have some amazing videos lined up just for you, so sit back, relax, and let's learn something new together. But before we get started, please make sure to subscribe to our channel so you never miss any of our latest uploads. Let's go! Science and technology. Simple physics. Which is heavier, a kilogram of steel or a kilogram of feathers?
Sister, this rock is so heavy. I wonder what the heaviest thing in the world is.
I don't know, but I do know a cool physics question. Which is heavier, a kilogram of steel or a kilogram of feathers?
Well, obviously steel is heavier than feathers, so a kilogram of steel must be heavier, right?
Not quite, brother. The answer is actually that they both weigh the same.
How can that be? Steel is definitely heavier than feathers.
It's actually a bit of a trick question. A kilogram is a unit of measurement that means the same thing no matter what it's measuring. Well, don't fall for it and say steel. The answer is that a kilogram of steel weighs exactly the same as a kilogram of feathers. Yup, that's right. They both weigh a kilogram. So the next time someone asks you this question, you'll know the right answer. Let's imagine a big sack of feathers and a small block of steel, both weighing 1 kilogram. The sack of feathers would have to be much bigger than the steel block to weigh the same. That's because steel is more tightly packed than feathers, which makes it denser. Density is like how tightly packed something is. If it's more dense, it takes up less space. So even though both objects weigh the same, the steel block is much smaller than the sack of feathers because it's more dense. Here's another way to think about density. It's like the amount of stuff packed into a certain space. To figure out density, we use something called mass and volume. Mass is how heavy something is, and volume is how much space it takes up. If we divide the mass of an object by its volume, we can get its density. It's kind of like figuring out how tightly packed something is. But wait, don't confuse mass with weight. Mass is different from weight, and it can be a tricky concept to understand. For now, just think of it as how heavy something is. Did you know that gravity affects weight?
No, I don't know.
Weight is actually a type of force. If you were to stand on the moon, you would weigh less than you do on Earth because the moon has less gravity. But no matter where you are in the universe, whether you're on Earth, the moon, or even floating in space, your mass always stays the same. Mass is like the amount of stuff you have in your body, and it never changes no matter what planet you're on or how much gravity there is. If you want to figure out how heavy something is, you can use a scale. But if you want to be extra scientific and figure out its mass instead, you need to use something called a triple beam balance. See, scales measure weight, which is different from mass. Mass is like the amount of stuff in an object, and you can find it by using a triple beam balance. So next time you want to do a super accurate science experiment, remember to use a triple beam balance instead of a regular scale. Finding an object's density is easy. All you need to know is how much stuff or mass it has and how much space or volume it takes up. Then you can divide the mass by the volume to get the density. It's like figuring out how tightly packed something is. To find density, we use a formula that looks like this. Density is equal to mass divided by volume. It's like a special math equation. Scientists use special symbols to represent the different parts of the equation. The symbol for density is rho. The letter P is the lowercase Greek letter rho, which is commonly used as a symbol for density in physics and mathematics. The symbol for mass is m, and the symbol for volume is v. We measure mass in kilograms, which is like how heavy something is, and we measure volume in cubic meters, which is like how much space something takes up. Density is measured in kilograms per cubic meter, so density tells us how tightly packed together a substance's particles are, kind of like how closely a bunch of marbles are packed into a jar.
Wow, but why do we need to know this?
It might seem like all this talk about density is just for scientists, but actually it's super important in lots of things we use every day. For example, gold mining and blood separation rely on knowing the density of different materials to do their jobs. Scientists also use density to help extract DNA and build really tall buildings that don't fall over. So, understanding density can help us do lots of amazing things and make our world a better place. Did you know you can actually see density in action by making a tower out of different liquids like syrup, vegetable oil, water, and dish soap?
No, I don't know.
When you pour each liquid on top of the other, you'll see that they don't mix together. They stay separate in different layers. That's because each liquid has a different density, or how closely packed its particles are. So, the liquids with a higher density sink to the bottom, and the ones with a lower density float on top. It's like a delicious science experiment we can try at home. Have you ever thought about how different parts of our body have different densities? Think about our muscles and fat. Did you know that muscles are denser than fat?
No, I don't know.
That means they take up less space in our bodies than fat does. But that's not a bad thing. Muscles help us move, run, and play. Fat, on the other hand, has a different job in our bodies, and it needs to be less dense so it can store energy. So just like how different liquids have different densities, different parts of our body have different densities too, and that helps them do their jobs. Have you ever been to a doctor's clinic for a blood test? Do you know how doctors measure the different parts of your blood?
No, I don't know about it yet, but I am very excited to learn more.
Well, your blood has two main parts, the liquid part called plasma and the solid part which has different types of cells like red blood cells, white blood cells, and platelets. Now each of these parts has a different density, which means they are packed differently. To separate them, doctors use a special machine called a centrifugation machine. This machine spins the blood sample really fast, which causes the different parts to settle into separate layers based on their density. After this, doctors can study each layer separately to see if there are any problems with your blood. So next time you go for a blood test, remember how density helps doctors study your blood. Let's give it a try. Build a liquid tower experiment. What you need: honey, concentrated dishwashing soap, water, cooking oil, and a glass jar or bottle with a lid. What to do: get a glass jar or bottle with a lid and add honey, concentrated dishwashing soap, water, and cooking oil in the given order. Observe as each liquid forms a separate layer, with the honey at the bottom and the oil on top. Cap the bottle and gently tilt it from side to side. You will notice that the layers move and switch positions but remain separate. This is because each liquid has a different density. Higher density liquids like honey sink to the bottom, while lower density liquids like oil float on top. Try other liquids like maple syrup or corn syrup to see how their densities affect the layer formation. By doing this experiment, you can learn about density and how it affects the way liquids behave.
Wow, I never thought about it like that. Thanks for explaining it to me, sister.
No problem, my brother. It's always fun to learn something new about physics. Thank you for tuning in, and I look forward to sharing more with you soon. Don't forget to hit the subscribe button and ring the bell icon to get notified of our latest videos. Until next time, take care and keep learning.